Hello folks! Now I will show you the very basic equipment which is indeed necessary to correctly perform the reballing process. We'll start from the very beginning. One of the most important stuff to remember is to use a proper flux. We recommend the Jelly Wharton flux. It is the best on the market, it is the best flux you can get. It doesn't bubbles, it smells kinda nice, and it is one and only professional flux. The next thing is the 3S solder rig. We use only the blue 3S solder rig. It is the best solder rig you can get because it can suck a lot of solder into it and it's very priced. The next important thing is this Wharton Total Clean Spray. This spray can be used to remove the flux after the soldering processes. It is fairly priced. You can easily buy it on eBay. It's the best spray. It's the best removal spray you can get. The next important thing is this vacuum suck out, the vacuum processor lifter. This is used to correctly, to safely remove the processor from the motherboard when it's heated. The next thing to remember is to have a proper soldering iron, resistive soldering iron. As you can see, the tip of the soldering iron is kind of big. It has to be the bigger one because it has a bigger surface which can accumulate the old solder from the motherboard and from the processor. And it is very important to remember that your soldering iron has to be at least 450 degrees Celsius compatible, because this soldering iron, when removing a lead-free iron, has to be heated to a high degree of temperature in order not to damage the motherboard or the processor itself. The next thing to have is this aluminum tape. As you can see, there are a lot of elements on the motherboard which has to be securely covered from the heat, because if they get heated up too much, they can get easily damaged. So this aluminum tape has to be at least 300 degrees of Celsius scale proof in order to correctly perform the reballing process. The next important thing is this wooden panel. It has to be a surface which do not conduct heat. A wooden panel is perfect to place the processor in order to solder the balls from above. The next thing is this cooler fan. A cooler fan is a very important stuff because it can cool down your processor right after you have it remove it from the board. So remember to place it next to the processor in order to cool it down. This next thing is a stencil. As you can see, we are using BGA tripods to put on new balls on the processor. Do not use manual stencils because the whole process of soldering with manual stencil is longer and it needs higher temperature, which can lead to a permanent damage of the unit. So we recommend you using these BGA tripods with these stencils which are mounted above the BGA tripod. Next, the balls are spreaded on the surface, the tripod is pulled down, and the balls are being soldered without any stencil at all.
Let's take a closer look at the RSX unit and at the cell unit. You can see the remains of the thermal paste. Sony uses low-quality thermal compounds, which get dried in 2 years' time. Which makes the heat accumulate inside the case. The RSX is the most hit-responsive unit. With the ILOT era, RSX is most certain to be blamed. ILOT mostly suggests a cold solder underneath the RSX. Sony uses lead-free solder, which tends to turn into cold solders. This movie shows you full reballing of the RSX. Lead-free solder will be removed, and then the RSX will be soldered back. In 90% cases reballing the RSX is enough. Enough to completely remove the ILOT errors. The thermal remains are to be removed. At first, scrap it gently off. Scrap it with a fragment of a plastic card. Do not use any liquids yet, because the compound will melt all over the board. Scrap off as much as you can. It's best to do it precisely before the board gets to the station. Small remains can be blown with compressed air. Now use the water Total Clean liquid. This liquid melts the thermal paste. The amount should be small. Gently polish the compound off the units. Also of the cell unit. Finish it with a alcohol The units are cleared. You can blow them with compressed air. This RSX area has to be precisely cleared. Let's secure the board now. This is a 60 gig version. It's the biggest board found in PS3s. However, All the PS3 boards requires hot temperatures. So particular elements have to be protected from overheating. On the top side we will preserve the RSX area. The allo tape must cover the elements around the RSX. It's worthy to preserve other BGA chips. Like the bridge. Also the capacitors. Now let's move on to the bottom side. Especially the underneath cell area. We can see the actual chip through the hole. The heat is not allowed to directly face the cell chip. Stick the hole with allo tape. Stick a dual layer, just in case. It's best not to hit the cell chip if not necessary. The bottom RSX area remains undercovered. Preserve the plastic ports. The board is secured well on both sides. The RSX area is perfectly covered. The capacitors. Attention! Remember to take the battery out. Some PS3 boards have directly attached batteries. Heated battery will surely explode. Now let's install the board in the tripod of the HE station. This chapter shows you how to install the board in the rework station. The board has to be supported firmly from the bottom as well. It cannot bend during the whole process. Move out the bottom supportive bars. The board corners have to be regularly supported.
Let us stop here for a second. I want to turn your attention to the board installation in the tripod of your BGA rework station. This is a motherboard of the PlayStation 3 60GB version. As you can see, when you're installing your motherboard in the tripod, it has to be supported firmly, because we cannot make the motherboard bend upward or downward. This is very bad. Why it is bad? Because when you remove the processor, as you can see, there are these silver-like dots here. And when you are clearing the old solder using your soldering iron, it is highly possible that the iron will remove, for instance, one of these dots. And if one of these dots has been removed, it is highly probable that the motherboard has been damaged permanently. So we cannot make the board bend, because if it bends, probably one of the leads here will fall out while clearing with soldering iron. So it is very important to make sure that the board has been supported firmly from the bottom using the sidebars, which has been shown in our movie. Or the second thing, you have to remember to stick the corners of the motherboard to the sidebars of the station. When it's supported from the bottom and when it's sticked on each and every corner, there is no possibility that it will bend downward or upward. It will stay straight, and the leads beneath the processor won't fall out. Sometimes you're dealing with other versions of PS3 motherboards, such as 80GB version, which, as you can see, is quite irregular. It is not a simple square shape, as I've shown you before on the 60GB version. So you have to make sure that this board is still sticked firmly and is supported from the bottom, and make sure that most of the corners, as you can see, are sticked. And also make sure not to cover the area of the processor which is to be removed with the bottom bars. This area has to stay clear in order to make it heat up and other stuff like that. So let's get back to the movie.
With the side parts of the station. The side pads cannot touch any electronic elements. Solder it to the board. In PS3 case, the corners are free of such elements. Loosen the sliders to adjust position. Put the board on the side pads. Make the edge of the RSX, which has the smallest amount of elements in front of, be clearly visible from an easy viewpoint. It is essential to observe the balls along the edge during soldering back the RSX unit. Block the side pads. Check if it's regularly supported. The corners are mounted. Plug the sliders to hold their position. Remove the board once again. Put the bottom bars back to the tripod. The bottom bars are very important. They prevent the board from bending inward. In the case of 60 and 40 gig versions, put them exactly here. Generally speaking, the board has to be supported, and the actual bottom bars cannot touch soldered elements and cannot cover the RSX area. This area has to be equally heated. According to your version, adjust the bar's position. Now adjust the height of the supportive bars. The height plays a great role. This corner is lifted. The bar is too highly adjusted. Reduce the height. And if any bar do not touch the board, increase the height. It's better to adjust it right now than to damage the board later. Let's check. The corner is still gently lifted. I will decrease the height slightly. Check again. And now if you notice anything, check it twice. This step is crucial. There are no doubts left. Gently press the board to check if it bends. The board should not bend inward. It's steady enough. If the board bends, the pads can be damaged, especially when clearing the board of the solder. Proper board installment prevents from such accidents. You have to stick the corners of the board with aluminium tape. You have to stick it to the side pads of the tripod. Small fragments should be enough to firmly stick them. The corners have to be additionally supported. The board cannot bend during the process. It's extremely important to stick the corners with alu tape. All the corners are sticked now. The board has been completely mounted in the tripod of your rework station. It won't bend now. The risk of thermal damage has been minimalized. The RSX itself will come out easily out of the board. And none of the pads shan't be taken off with the iron strip during the clearing. Prepare the tools before you heat. Cooler fan to cool the RSX down. A vacuum lifter to lift up the RSX to suck it out directly from the motherboard. A jelly Wharton flux. A freer solder wick to clear the old solder. A long wooden toothpick to check if the RSX moves. A resistive soldering iron with temperature up to 480 degrees C. Do not use cheap-ass soldering irons. A metal sponge to clear the iron tip. Now let's start the machine. Set the bottom lamp temperature to at least 310 degrees C. Remember to set the rest of the parameters of your Archie station. For Archie station, see the calibration movie for details. 310 degrees C from bottom is enough to clearly heat up the board. Set the upper lamp temperature to 280 degrees C. According to upper lamp, the time is more important. The time is limited by the RSX movement. Turn on the bottom lamps. Put the upper sensor next to the RSX. Make the temperature sensor touch one of the edge of the RSX directly. Bottom lamps have to make the board reach 150 degrees C from above, without usage of an upper lamp. This temperature display is to be observed now. First, wait until it reaches 100 degrees C. The temperature is 100 degrees C now. Take off the sensor for a while. And now squeeze some jelly flux around the RSX. Make it float underneath the RSX. Small amount should do the trick. Put back the sensor. Again, make it touch the RSX directly. And again, observe the upper temperature display. Now wait until it reaches 150 degrees C. We will use the upper lamp of the station. The temperature has reached 150 degrees C. Place the upper lamp 4 to 5 centimeters above the RSX unit. Turn the upper lamp on. Using the wooden toothpick, check if the RSX moves. If so, turn off the lamp and suck out the unit and clear the board. Observe the timer. In PS3 case, it takes more or less 160 seconds from now to make the RSX solders melt. Check it constantly for the movement. Time has reached 100 seconds. Wait patiently, the moment comes after 150 seconds, mostly.
Hello folks, we have to stop here for a second because the sequence of the actions which is to be carried out in a second now is very complicated and has to be done very quickly because the motherboard is very hot right now and it's best to quickly clear it up and cool it down as soon as possible. So, the first thing, when you feel using your wooden toothpick that the processor has moved slightly, the first thing you do is to take out the upper lamp. You just take it up and slide it back. And now you turn off the bottom and the upper lamps. Next, you suck out the processor, as we've shown you before in our instruction movie. When the processor is sucked out, you have to place it on a wooden panel. But remember, place it on the metal pad, facing down. And then place a cooler fan next to the processor and quickly cool it down. If you quickly cool it down, there is probably no possibility that it will be damaged because of the heat. When the processor is removed, remember to take the jelly water flux and squeeze it down to the pads of the graphic processor. When squeezed, you'll have to form a ball made of solder. Make it a ball of PB solder. And when this ball is formed, remember to take your soldering iron and drag the ball through the pads of the graphic processor. But do not touch directly the motherboard with the tip of your soldering iron. Touch it indirectly with the solder ball, just dragging it through the pads. The next thing you have to do is to use solder wick. The solder wick can damage the board if it's not used properly. Remember that when you use a solder wick, the tip of your soldering iron has to be covered with solder. So just melt some solder on the tip of your soldering iron and then touch the solder wick. Touch it for a few seconds to make it hot, and then touch the board and gently drag it through the pads of the graphic processor. Do it gently. And if you're doing it for the first time, it's better to practice on some used up motherboards or some previously damaged motherboards. Because if you will be doing it for the first time, there is a high risk that the board will be damaged permanently. So thank you for your attention and see you soon.
If it was soldered with lead, the time would be much shorter. If the time reaches 150 seconds, check it more intensively. In this case, it has moved after 140 seconds. Now, turn off the lamp, suck out the processor using the vacuum lifter. And now, put the RSX upside down, but do it carefully and gently. It is very hot. The metal pad on the top of the RSX is very hot. Down with the cooler fan. Place it no closer than 20 centimeters from the unit. And now let's clear the board of the old solder. The lamps are off, but the board is still hot. Squeeze the jelly flux on the RSX spot. Use the previously heated iron to clear the old solder. Form a ball out of a lead solder. Drag the ball through the RSX pads. And then place the ball on the alloy tape next to the spot. Now use the 3S solder wick to remove the remains. The iron tip has to be covered with solder every time you use the 3S wick. Press the wick gently with the iron tip. Now move it slowly, sucking the old solder out. Do not force it if you feel any resistance. You can see the pads becoming visible. Remember, the tip has to be covered with lead solder. A thin layer of solder must always be placed before you use the solder wick. All the area is cleared. Remember to turn the cooling mode of the rework station right after you've finished the clearing process. Turn on the cooling mode. The board must rest for at least 15 minutes now. Do not move it. Put the RSX in the PGA tripod. It would be easier to clean it. The unit should be placed regularly. It would be useful later. By regularly, I mean matching the lines marked on the surface of the tripod. It should be firmly attached.
Welcome again, folks. We have to stop here for a second. I will explain some basic rules about clearing the processor. As we can see, this processor has been removed from PS3 motherboard. It has the old solder balls all over the bottom side of the processor. We can see it. Before we solder back our new balls, we have to remove the old solder. When we are attempting to remove the old solder, we have to remember that the soldering iron has to be heated up to at least 450 degrees of Celsius temperature scale. The second most important thing is that we cannot touch directly the processor with the tip of the soldering iron. Before we use the solder wick, we have to form a ball of solder, as we did when we were clearing the motherboard, and we have to gently drag it through the bottom surface of the processor. And then we have to remember one thing, that the middle of the processor is very tricky. When you are dragging a solder ball, start with the sides of the processor. And then, when you are attempting to clear the middle side, remember that you cannot have too much solder on your tip. If you are attempting to drive a huge ball to the middle, it will probably stick to the middle, and then you will have the trouble with removing it. So remember that the solder ball for the middle clearing process has to be a small one. And yes, when the solder is cleared, we have to finish the process with 3S solder wick, as we did with the motherboard. The same rules apply. We have to melt some solder with the tip of the iron. The tip of the iron has to be covered with some solder, and then you touch the solder wick to gently heat it up. And when it's heated up, you will just gently drag it through the surface of the processor, gently. All the details are shown in our movie, so I guess we can attempt the clearing process of the processor. So let's move on.
Squeeze some jelly water on the surface of the unit. Smear it all over the RSX surface. Take the iron and form a ball of a lead solder. Same trick as with the motherboard. Try not to touch directly the processor with the tip of an iron. First, drag the ball among the edges of the unit. Do not drag it through the middle part yet. Try not to touch the RSX directly with the tip. Now move on to the middle. Reduce the solder ball, only small amounts now. 2 or 3 times smaller than with the edges. The solder tends to stick to the middle part of the unit. Do it slowly and gentle. If the ball is small enough, it won't be a problem. Old solder is almost removed. Finish this stage with 3S solder wick. The iron tip must be covered with lead solder. Remember to cover the tip of your iron before you use 3S wick. Now gently press the wick to the RSX surface and slowly remove the remains. Let the 3S wick suck out all of the old solder right from the surface. The iron tip temperature should be more than 440 degrees C. It's best to adjust the temperature up to 470 degrees C. These actions requires practice, so try to pay attention here. Take a break once in a while. In order not to overheat the unit. Take all the precautions with the middle area. If you feel any resistance, do not tear the wick, do not pull it too hard. Remember to cover the tip of an iron with lead solder every time you use a 3S wick on the surface of the processor. If you have missed a spot. The surface has been cleared. None of the pads below the processor has been damaged. The RSX is completely cleared, but it's best to take a closer look and correct if any spot has been missed. It's best to do it precisely. Now let's wash the unit with alcohol. It's best to use a ultrasound bathtub. Now release the unit. Put the RSX into the tub. All the flux remains will be washed off now. Put the RSX back to the BGA tripod. Adjust the position. The position should be centralized. Most of the tripods have marked lines on the surface. The RSX should hold firmly. Swab the surface with alcohol. The purity plays a great role here. Let's check the unit. Check the surface for any missed spots. If it has any solder bump, remove it. It has to be clean, with visible parts. Alright, it seems to be fine. Now let's adjust the stencil to the pattern on the RSX. We have to hold it in the right position and then block it. Stencil hose must cover all the pads on the RSX surface. All the RSX pads should be visible through the holes of the stencil. Try to make a precise match. Now block the stencil to hold its position. Screw it gently. As you see, all the holes fits the pattern. Remove the stencil and squeeze some gel on the RSX. Small amount should do the trick. And by small I mean a very small amount. Using a plastic card, form a thin layer.
Hi again, folks. Let us stop here for a second to emphasize the importance of this action, which is now being carried out on our screens. You have to remember that the layer of the flux has to be thin and regularly distributed all over the bottom side of the processor. If the layer is irregular or too much flux has been gathered in one place, when the processor will be heated with the upper lamp of our workstation, there is a high risk that some neighboring balls will melt together, and then we'll have to again clear it out and repeat all the process. So in order not to repeat the process all over again and all over again, we have to make the layer thin and regular. So take the plastic card and patiently distribute the layer, removing the excess before it gathers in one place. And yeah, that's the very basics of reballing the processor. So remember, this is a very, very important step. So see you again soon, and let's get back to our instruction video.
The layer has to be thin and regular. Remove any excess. It's important to do it precisely. Any excess of jelly can ruin the ball resoldering. Excess can make balls touch and melt together. So make sure that the layer is thin, regular, because it's very important. It's better to do it precisely right now than to correct all the process later. Put on the previously adjusted stencil. Now pour out the balls. You can use either 0.6 millimeters or 0.65 millimeters. It's best to use solder balls which contains lead. Lead balls are much better. Grab the stencil and vividly rock it from side to side. Pour out the excess. If any hole is not filled, you can repeat the action. Single holes can be filled manually later. All the holes are filled now. Grab the stencil and drag it down gently. Remove the stencil. New balls are placed, all matching the pattern. Let's take a closer look. Correct any suspicious balls with a gouge. There's always a blind ball in here. The stencil is to be blind. It has a one hole too many. What's funny is that all the stencils I've seen had this so-called malfunction. Now mount the wooden panel. In the station, remove the bottom bars. Wooden panel is resistive to heat, so the RSX will reball faster. It's best to use a panels, not any true wooden decks. Place the corners on the side pads. Now stick the upper sensor with alu tape. Take a bigger fragment of alu tape and stick the sensor firmly, because the high temperature could make it go away. Stick it firmly, check it. Now release the unit. Grab it with fingers. Hold the corners. Gently transfer it to the panel. Make the RSX touch the upper sensor. take a final glance at the RSX surface. Everything seems to be fine, so let's start the heating. Place the upper lamp 4 to 5 centimeters 6.
Hi again, folks. Now I'll show you how you can make sure that the balls has been properly soldered to the surface of the processor. It is very simple. The most important thing is our eyesight. The observation will be the key to performing this action properly. As you can see, when you have placed the new balls from the jar and taken out the processor from the tripod, you can see that the rows here of the balls are irregular. Some of the balls are closer to one another, some of the balls are more far one than another. So when the solder is heated up to 180 degrees in the Celsius scale, the rows will form the position straightly. The pattern will become a regular one. So we have to observe the surface of the processor and see if the pattern is becoming regular. If it has become regular, we'll have to turn off the upper heating lamp and place the cooler fan next to the processor to cool it down. But remember that the middle of the processor can take some longer period to form a regular pattern here. In some cases, you'll have to wait to 200 degrees in the Celsius scale to make it become regular in the middle. So do not be afraid if the temperature rises above 180 degrees temperature. It is not some strange thing to happen. It occurs sometimes. And remember to watch, to observe the processor, to observe the pattern. And if it's regular all over the surface, the balls are perfectly stick to the bottom of the processor, and we can cool it down. Thank you for your attention, and see you soon.
Centralize the position of the lamp to make all parts of the surface of the unit heat up equally. Turn the lamp on. Set temperature limit to 280 degrees. However, a much lower temperature will be used here. Observe the timer. It takes 260 seconds approximately. If the timer is set below 260 seconds, you will have to press the reset button after some time has passed. Otherwise, the lamps will be turned off, and if you press the reset button, the clock will start. It prevents the lamp from switching off. Observe the temperature measured nearby the unit, here on this display. Lead balls will start to melt when this temperature will be about 180 degrees C. Using lead-free balls, this temp is more than 240 degrees C. However, the RSX always heats pretty long, and that's because it has a large fragment of metal pad, which cools down the whole unit during the process. (180 C), 260 seconds have passed, and the pattern isn't ready yet. The middle hasn't settled yet. We have to wait some more time and let the processor heat up a little bit higher. And now it's done. The middle has settled. Remove the upper lamp, turn it off, and drag it to the side. Cool the unit down with a cooler fan. As you can see, the RSX has been easily reballed. Such perfect result can only be achieved using this method. Now let's remove particular tape parts. In some area, the tape could disturb the process, especially in the RSX area. This spot has to be regularly heated. What is more, the tape would cover the balls, which we have to observe. The solder contains lead. So the soldering temperature will be much lower than in the case of unsoldering the unit. Now let's clear the motherboard. Using a Warden Total Clean liquid spray. The flux remains can be hard to remove. Gently mix the spray with the remains. It's best to use a wooden toothpick in order not to scratch the board. Try to do it precisely. You can leave the board for 10 minutes to make the flux remains melt. And then sweep it with a anti-static cloth. Mostly the action has to be repeated to clearly remove all the remains. And again, use the anesthetic cloth. Finish it with alcohol. To completely remove the old flux and any dirt that could possibly get there.
Hi. Some of you may have noticed, after removing the processor from the motherboard of PlayStation 3, we can see 4 marked dots on each on each and every corner of the motherboard pads here. Sometimes there is a small resistor or capacitor attached to that corner. What if the capacitor has been touched or removed? Well, this is not a problem because these capacitors are not connected to any circuit on the motherboard. They're just simply used as a some kind of pad to make the processor solder correctly, because in the factory the whole process is controlled by a machine, so it had to have some pads in some versions. In some cases, these 4 dots are not holding any capacitor or resistor from the production day, because some motherboards just lack of the capacitors. You can just remove all the capacitors. As I've said, they are not necessary to correctly solder the processor to the motherboard, so if you have touched one of them and if it has changed its position, remove it off the board, because if it has changed its position, it can push the processor too high and the whole soldering process will fail. So these capacitors, resistors are not necessary to correctly solder back the processor. So do not focus your attention on them. We'll explain later about, we'll say more about them later in the movie. So let's move on with the reballing process. See you soon.
The surface has been cleared. Sweep it with compressed air. One last word about the capacitors. In many cases we found a micro capacitors in here on the corners of the RSX spot. These are not connected to any circuit. They are here to support the RSX during the soldering. However, some boards doesn't have any of this at all under RSX units. These capacitors are not necessary to remain. I repeat, not necessary to remain. Do not worry if you have accidentally touched it with iron tip or removed it accidentally during the unsoldering. And if you see that one has changed its position, remove it completely out of the board with soldering iron. The RSX can be soldered without any of those. The ball observation and the lamp temperature are the key. In some cases the caps aren't present here at all, so it's best to deal without them. Take a look at the corners and check if the caps have moved. As I've said before, a moved cap is probably to be removed out of the board completely. However, in this particular case, these capacitors, these micro elements on the corners, weren't here. There were no caps here at all, so it doesn't matter in this case. Let's install the board in the rework station. Do not apply the bottom bars yet. Release the sliders. Release the side pads. Remember the basic rules concerning the installment. Support the corners with the side pads. The RSX spot should be placed right above a lower lamp. As shown here. The spot right above the lamp. It's crucial. This spot has to be equally heated. Adjust the corners and block the position if it's rightly set. Block the sliders now. Put on the bottom bars. Put them as they were before. Install back the board. Check if it bends inward. Adjust the height of the bottom bars. It doesn't bend at all now. Remember to stick the corners with alu tape. The board has been installed. Now let's squeeze some jelly warden. Small amounts should be good. Using a plastic card, form a thin layer, a thin and regular layer of Warden flux. Remove the excess. Try to do it precisely. Now let's put the RSX on the board. One edge of the RSX has this gap in the pattern. This gap has to face the gap on the board. The corners of the RSX should match the marked corners on the board. The corners on the board are always marked, either with a solder or a microcapacitor stick to the solder. These marked four corners should match the four corners of the unit. The corners are matched the spots on the board with the spots on the board. Put on the upper temperature sensor, make it touch directly to one edge of the RSX. Turn on the bottom lamps, set the temperature to 310 degrees C. Observe the upper temperature on this display. Wait until 150 degrees C. Only after 150 degrees C the upper lamp will be used. Now the upper lamp doesn't take part in any of this. It's resting aside, switched off. Now listen how to know if the RSX has settled. Observing the balls is the key. The balls has to melt along the whole edge of the RSX. Only then the RSX can level down. And this would mean that the heating is to stop. Prepare the cooler fan just in case. Melting balls become shiny. Wait until the upper side reaches 150 degrees C.
Hello. As we can see, the temperature on the motherboard, on the top of the motherboard next to the graphic processor, is slowly reaching 150 degrees, which means that we will use the upper lamp to heat the processor from above. When you're placing the upper lamp, remember that the processor cannot extend, the lines of the processor cannot extend the lamp because it has to be heated all over the upper surface. So make sure that the lamp is facing directly the processor. And make sure that the lamp is at least 2-3 centimeters above the processor. it can't be further than 3 centimeters. It has to be placed closely to the processor because this metal pad on the processor has to be heated up correctly in order to make it solder properly. So when the upper lamp has been placed, you have to observe the line of the balls here, which has been shown on the movie with a special zoom, so you will see it. The balls will begin to melt, and you will see them shiny, becoming melty, and the processor will fall off all over this line. And when it will fall over all line, you will have to turn off the lamps and begin the cooling down process. This stage is probably the most trouble-making stage of the whole reballing process. It is the most difficult part, so you'll have to practice it. And if you've never done it before, practice it on some previously damaged boards, because, at first you'll have to get the hold of the whole process, get the hold of the falling down of the processor, and it's experience, it's needed. It's indeed needed here. So good luck, and see you soon.
(150°C). Now remove the upper sensor. We will use the upper lamp. Place it max 4 centimeters above the RSX. The metal part has to be heated now. The balls are likely to melt any second now. Focus your sight on the balls. The processor is settling. It has settled along the whole edge. Stop the heating and turn on the cooling mode on your rework station.